A team in the Nutritional Biochemistry Lab at Johnson Space Center identified in one study that even before flight, astronauts with vision changes had higher levels of one-carbon metabolites in the blood, such as homocysteine. That's one of the amino acids that makes up all of the proteins in our body. Well, that led to a follow-on study that has delivered some compelling results that are sure to have implications to space as well as life on Earth. I spoke with Scott Smith, one of the principal investigators for these studies, to find out how they put 2 and 2 together.
When the vision issue jumped up, I guess about 6-7 years ago, we had been doing the nutrition SMO study on space station where we were collecting blood and urine, and we told the docs, we told the human research folks that, we have a lot of data. Tell us who had vision issues and who didn't, and we'll see if there's anything there that can help. And it was February 18th of 2011. It was a Friday afternoon, about 3:30, and Sarah Zwart came in and sat down in my office and said, "There's something going on with one-carbon metabolism." And what she meant by that was that some of the biochemical metabolites that we looked at were higher in crew members that had vision issues compared to those that did not. And that was pretty striking. Not only that, they were higher pre-flight, and that is what really shocked us.
And it opened it up to even more work then.
Indeed. We had a lot of circumstantial evidence, things that pointed to the idea that there might be something about the genetics of this pathway that are causing these vision issues. And we put in a proposal to go off and look at those, some of the genes. We sat down with 70 crew members and said, look, we want to collect some blood. We want to look at your genes. We're trying to figure out this vision thing. And all 70 of them gave us blood.
That's kind of unheard of, right? All of them agree.
That is unheard of.
So they know how important this study is.
Absolutely. And well, moreover, it tells you how important the problem is.
Right.
And the fact that we had some preliminary evidence and the fact that we were trying to chase this down, they were more than willing to help us.
So then you got what you wanted, and what happened?
And what we found was, in a sentence, we found that there's a genetic predisposition for some astronauts to develop ocular issues during spaceflight. Now, it's not a smoking gun. We didn't describe everybody that has vision issues or ocular issues, depending on how you want to call it. So there's a little more work to be done, but what we've shown is that there's an association between B vitamin status, things like folate, B12, B6, riboflavin, and genetics in who develops these issues.
So now that you have this information, what do you do with it?
Well, we need to go try to figure out what's in the middle. We need to figure out the black box, if you will, that what is it that's different about these individuals with these genetics that leads them to develop vision issues during spaceflight.
And was there a difference between men and women?
Well, the ophthalmic issues during spaceflight, frank vision issues have only occurred in men during spaceflight. And the common thinking is that, well, that's likely because we haven't flown enough women. So one of the more intriguing aspects of this is that when we were starting to pull the data together to publish it, again, Sarah was working up the data, was reading through the literature, and what she found was a clinical population that had several of the characteristics that we see in astronauts. Higher concentration of these same chemicals that we were looking at, higher concentration of these genetic differences, thicker retinal nerve fiber layers, lots of things, 7 or 8 different things that this clinical population had that the astronauts also have. And the clinical population is women diagnosed with polycystic ovary syndrome, which is the most common cause of infertility in women. It affects 10 to 15% of women, which is a phenomenal number for incidence. And again, the characterization relative to the astronauts is striking.
It's something you weren't looking for, but really kind of stumbled upon.
Absolutely.
So now that leads to more work with the Mayo Clinic, correct?
Indeed. And what we've done is we proposed a study. We brought in some collaborators, and we're now about to embark on a study with co-investigators at the Mayo Clinic, an endocrinologist up there, Alice Chang, and a neuro-ophthalmologist up there, Chen, and we're going to study women with polycystic ovary syndrome and with women with intracranial hypertension to see if their genetics and their biochemistry indeed matches what we found with the astronauts.
So if that's the case, then what's the result? What's the outcome? What do you hope happens?
Well, the first step is that, this will give us confidence, and this will give everybody confidence that we're on the right path. What we then need to do is study women with this syndrome to find out what's different about them that might lead them to have ophthalmologic issues if they went to spaceflight. And to get at the mechanism of what's causing this disease, both this disease in women with PCOS and this disease in astronauts flying in space. And if we can find out that mechanism, that will allow us then to figure out how do you treat it, how do you change it, how do you reverse course. And the implications of that on both ends, for NASA and for 5 to 10 to 15% of the population, could be staggering.